Hey, what's going on, guys? Games here. In this video we're gonna start coding our Hex Editor. So what the Hex Editor is, it's the application that allows you to type in digits and letters from A to F, A, B, C, D, E, F, representing the hexadecimal kind of values, and they get this kind of ASCII characters that we have when we press a key are being translated into the hexadecimal values, okay? And then they get stored into a certain location within the memory. So that's the core idea of the Hex Editor. And what it gives us, what it gives to us is the opportunity to type machine codes directly into the certain memory kind of range. Within the certain memory range, we will define this in our memory map now. And if we then create a run command, just literally jump in from the shell to that certain particular physical address in random access memory, it would actually start executing whatever codes, whatever machine codes we have there. So Hex Editor is the most simple, the most basic way of actually coding on a computer, and it's also very minimalist as well. And that would be, well, for now, that would be the only available option for developing boot sector games and apps not outside of the GameOS but inside the GameOS. So without further ado, let's actually jump in. So I'll start with altering this memory map, and then we'll create a new file. So for now, I will probably be overriding the games, because the problem is that the games, they're great, they're absolutely fantastic, but first of all, I want to have the games after the system utilities. That's the first thing to consider. And the second thing to consider is I just want to have, like, well, let's say game switches like to the graphical mode, or like changes the color of the text, so we need to restore it back. So we'll need a helper utility to do that for us. And just because, since I've removed that functionality from the shell itself to make it more like in Linux style of Linux terminal style or Windows command prompt. So yeah, that's gonna be another thing to consider. So for now, we would be overriding the games for the next few utilities, but the games obviously might be added later on. But again, like I feel like it's really more important now to cover the system stuff, and we can always return back to games. All right, so let's start with the memory map. So I've been playing around with a certain memory location, which is 7700 in hexadecimal, and let me just take the calculator, and I want to calculate one little stuff. So files, and by the way, hold on a sec, did I ever, I didn't actually yet provide the stack here as well. So I don't see any stack. Yeah, so yeah, and that's because the stack didn't actually have any limits. Now it has, now it does. Okay, so let's say 7C00, which is our which is the boot sector, where the boot sector starts, and minus 7700, which would be the starting point for the memory to be directly accessed by the Hex Editor. So, and this is equal to 500s. Okay, and if we now convert this to decimal, this would be the number of bytes being used for a stack. It's hard to say whether it's good enough or kind of big enough for a stack. Okay. But you know, guys, I just thought that probably it's not even the matter of the size of the stack in bytes, but rather the matter of, well, I just want to show you one little thing. So if we have a look at real mode download memory map. I just want to start with the first available address, basically, and I will now explain you why. I didn't test this, but this should be working like whatever other segment, basically. So here, starting from 500s, starting from this address, and then for 500s plus 500 plus 512 megabytes. And then all the rest would be the stack. But the problem is not the problem. The point is that for whatever third-party games or apps running under GameOS, it would be they may redefine the stack somewhere, and if the Hex Editor's memory is too close, well, on the other hand, even if the Hex Editor's memory is too close. Well, let's say if they use stack there and there is already some, well, in that case, it's not the big deal as well. Well, anyway, yeah, let's just take this address. I don't know, let's just take this address. It's quite pretty okay. So this one and here like this, and now we need to say 500s. So 512 in decimal would it be 200s in hexadecimal, okay? And now we need to say 500s plus 200s in hexadecimal, and we have the 700s. So here up to 0x0000700, 512 bytes we have for hex hex editors, let's say hex editor scope to write, hex editor scope to write, let's say hex editor's source file. Okay, I think this might be just as good. So now so this like +1. So, well, actually, no, hold on a sec. It's not like this. 700s, no, -1. 6FF. So actually, this is gonna be, sorry, 6FF. And now starting from here and up to, say, um, 7C 00 -1 7BFF. So here and up to 7BFF, and now I just need to calculate the number of bytes. So 7C00 minus I guess this value would be okay, minus 700s, and in decimal, so this is the number of bytes that we have for a stack. So because bytes stack memory, because you remember that we have defined the stack here as base pointer points to 7C00 here, and also in the shell, okay, and also in the list. Okay, so this goes from one file to another, because if we just run some third-party app, it might override the stack. That's the reason why I consider the stack, why I reinitialize the stack in every single app. If there was no third-party apps or games being intended in this operating system, in that case it would be just enough to do this once in a bootloader. But since there might be some other kind of apps that might override the stack location, like this base pointer and the stack segment as well. That's the reason why I keep tracking this in every single app. It takes some extra bytes, but hopefully results in a greater stability. So I think that's worth it. Okay, guys. Okay, so now, now we've defined here. Here is the stack. Here is the Hex Editor source file. So where we're gonna be. So here at this particular place, we're gonna be running our. We're gonna be running our application. So we're going to be writing the bytes there, and we're going to be jumping to that location to run whatever we have written. Okay, so I hope that's clear. Now, let's change this to list. And instead of a snake, we will have an edit command. And this edit would be our Hex Editor. Okay, so now let's create a new file. So let's call it edit.asm. All right, edit.asm, and let's open. Now I just want to grab everything from list just to provide the boilerplate code. So do we need an offset for file names? I guess not. Shell segment to jump there back. Yes, we will need that. Files address, I'm not sure, probably not. Okay, initialize and stuff. So we don't want to load. The file from USB flash drive. What else? We don't want to print files, and we don't want to jump to this shell segment at least yet. So we don't also need the print file routine. We need the print string routine, definitely. We don't need the read sector routine. Okay. This message is no longer on the cards. Okay, new line would be useful, and I guess we don't need these guys as well. Save. So well, at very least, let's actually, hold on a sec. Let's shell segment. Let's just create some sort of a placeholder for now. I can simply say, so let's just say like test and define byte Hex Editor. Okay, and the new line, 0 terminating carriage return and 0 terminating character at the end. Here we can say move si to a test to si and call print string. So now if I type this command, it should be like when I add the command and when I type edit, it should just print Hex Editor and escape. And in order to make it escape, we need to say jump shell segment and the 0 offset. That's pretty it. Okay. Now files. So here instead of the snake, I want to have the edit command. Right, and now in the build toolchain, so assemble bootloader, assemble game list system utilities. Yeah, starting from here, so this might be treated as the system utilities. So let's take edit asm binary edit.bin. All right. Yeah, by the way. So yeah, we don't change the number of sectors, so this is okay for now. And here instead of snake, I want to add my editor. And yeah, one more thing, guys, I forgot to do is in the files we need to add 10 because it should be 8 bytes also. 4 bytes for letters and 4 trailing like terminating zeros, like placeholders. All right, so Is this really enough? Well, let's see. So let's open the terminal in the current working directory, and by typing run.shell. Okay, we got some errors, comma, colon, edit 39. It probably treats this as, okay. Let's just, yeah, probably this treats as an instruction, I believe. Okay, so let's type some different variable name. Now it seems to be working. So we have edit being available now, edit, and we got the Hex Editor placeholder firing the message to us back and returns to shell, which means that from now on we can actually start working on Hex Editor's code. So yeah, I think let's just stop here because there are really lots of things to do, and just really I want to try to keep videos shorter as opposed to what how long they were before, and would it be dividing and conquering all the procedures, all the functionality within the Hex Editor on its own, so to bring more light in regards to every single part on how exactly it works. So hope that makes sense. Okay guys, so yeah, this is it from my side in regards to this video. So thanks for watching, until the next time, and take care.